AI Think Tinker Learn. This is part of my System Design Essential series. The goal here is to give you a mental model of system design topics. We're breaking down today GraphQL architectures. This is a concept first introduction to help you build your system design foundation quickly. If you want to see a deep dive on the trade offs or a specific case study, let me know in the comments. Let's get into the technicals now. Why do you move away from a GraphQL monolith? Because under scale, the monolith breaks in four ways. First is the organizational coupling, different teams fighting over the same deployment pipeline. Second is independent scaling. You're forced to scale your entire application even if only one small feature is under heavy load. Third is a technology lock in. You're trapped in one stack. Finally, there is a schema blast radius. One breaking change to a shared type can detonate your entire code base. Federation is the architectural answer to these scaling pains. The federated supergraph architecture introduces three core layers. The gateway or router act as a single entry point, providing a unified city directory of the client. Below that is an orchestration, where the gateway dynamically routes execution to specific subgraphs. Each subgraph owns its own schema, logic, and isolated database. This provides true isolation. The product team and the reviews team can deploy the code independently without ever stepping on each other's toes. The gateway isn't just a proxy, it's an intelligence layer. It doesn't fetch data itself, it plans the fetching. When a query arrives, the gateway performs DAG construction, passing the query into a dependency chain called a directed acyclic graph. It identifies which fields can be fetched in parallel and which must wait for the previous results. This parallel execution ensures that the gateway dispatches requests to subgraphs as efficiently as possible, minimizes total latency. How do these independent services talk to each other? The linchpin is the add key directive. It allows a subgraph to declare a primary key, letting other subgraphs reference a record by ID alone. This enables zero-touch extension. For example, the review subgraph can add reviews fields to the product type without ever touching the product's team's codebase. You get two separate deployments, but to the client, it looks like one seamless unified schema. Federation relies on a specific vocab of directives. Add key declares ownership of a type. Add external marks a field owned by another subgraph, while add extends allows you to add fields to that type. For performance, we use add requires to signal dependencies and add provides to skip extra network hops if we already have the data. Finally, add inaccessible, add deprecated, and add override allows for safe schema evolution and migration of field ownership between services. Now, let's talk about the N+1 monster, which is at the database layer. Imagine a naive librarian. You ask for 100 books and their authors. The librarian walks to the catalog once for the books, then makes 100 separate trips for each author. That's 101 database round trips. At just 10 milliseconds per trip, fetching 500 posts would result in 5 seconds of pure database latency. This is the classic performance killer in GraphQL resolvers. The fix is DataLoader, a two-phase batching utility. In phase 1, it collects all requested keys within a single tick of the event loop. In phase 2, it batches them to a single database query like a SQL in clause. DataLoader also provides per request memoization, catching duplicate keys instantly. This collapses 51 potential queries into just two, drastically reducing the load on your database. However, DataLoader has a silent killer, the same order contract. The batch function must return results in the exact same order as the input keys and return the exact same number of results. If a database sorts results differently, say by ID ascending, DataLoader might silently return the wrong data to the wrong user. The fix is to always explicitly map or sort the database responses to match the input key array before returning. In a federated world, we also face the distributed N+1 problem. This is the network hop spam. If a naive gateway fetches 100 orders and then calls the user subgraphs 100 separate times laterally, your network will drown even if your database is fast. Each query is now a physical network hop across a service boundary, compounding latency exponentially. Fixing the database won't help if your network layer is overwhelmed. Federation built-in solution is entity batching. Instead of making 100 lateral calls, the gateway collects all IDs across all resolved objects and makes one batch call to the targeted subgraph using the underscore entities query. The target subgraph then implements an underscore resolve reference resolver to handle the batch payload. This collapses 101 network calls down to 2, completely neutralizing the network overhead. In a fully optimized request lifecycle, you have two layers of batching working in concert. The gateway batches at the network layer and the data loader batches at the database layer. The result? You can process a massive query spanning multiple domains with only two network hops and one database query. This synergy is what allows GraphQL to scale to enterprise level traffic. To shave off even more milliseconds, we bypass the critical path. The add provides directive allows the query planner to skip a network hop if a subgraph already has a copy of the required data. We also use persistent queries, where client sends a hash instead of a full query string. The gateway caches the query plan for that hash, skipping the expensive DAG planning step entirely. This saves 5 to 15 milliseconds of CPU time on every repeat request. When choosing an architecture, this use this decision matrix. Small teams with few services should stick to a monolith with DataLoader. The overhead of federation is a net negative here. Large teams with low traffic should also stay monolithic to save on infrastructure. Federation is truly an organizational scaling tool, masquerading as a technical one. Use it only when organizational coupling becomes your primary bottleneck. To wrap up your mental model, think of federated graph like a city hall. Each subgraph is an independent department building. The gateway is the central 311 operator. The add key is a citizen's ID number. Data loader is a smart clerk who waits for all requests before making one trip to the basement. Now for the community. Have you ever accidentally DDoSed your own service by ignoring the N+1 problem? Tell us your stories in the comments. Don't forget to like, share, and subscribe to CSAI Think Tinker Learn for more system design essentials. See you in the next one.